Alright, welcome back to another math video. We are looking at Year 12 integration, particularly the approximation methods, and even more particularly the trapezoidal rule, and even more particularly some examples on the trapezoidal rule. So, what we're going to do, we're going to start off with an example, and our example is going to say find an approximation for this here. It's going to say find an approximation for 1, 4, and we're going to put in let's say dx on x squared. Sweet. What the hell? What I'm going to do, I'm going to rewrite this a little bit, just in a slightly more convenient sense, and I'm going to explain it for you. So I'm going to make this 1 on x squared dx. Explaining what's going on. So what we're going to have here, this here isn't the integral sign. It's actually an S. It came as an S, but it is written differently to an S now. It's because we're summing a bunch of small parts. We're looking at a sum, okay? And we're summing, in this case, between 1 and 4. So the sum between 1 and 4 of what's, well, hang on, dx. All right, let's draw a diagram. So, I've got some curve. We're looking at x values between 1 and 4. So the 1 and 4 here tells us we're going between 1 here and between 4 here. This part in the middle here tells us our function, so that's our graph. That's f of x if you like. So f of x is 1 on x squared. I'm just going to tell you it looks something like this, where we are. So f of x equals 1 on x squared. If you didn't get it, you can put the dx out the back. So we're summing between 1 and 4, and dx means the x-axis. So the x-axis going between the curve here, so the curve here, the x-axis told by that, and the lines 1 and 4. So between 1 and 4, 1, 4, x-axis, yes, 1 on x squared under this curve. So we're looking at finding this area in here. Okay, separating them all out is a necessary part of integration, and it's something we'll need for our trapezoidal rule. So we're asked to approximate this using the trapezoidal rule. So we are looking at drawing a trapezium in underneath the curve here. A trapezium, something like this. Just a nice, simple-ish example. And that would be our trapezium. In terms of our distances, we have the point 1 here. So the parallel sides, that there is parallel to this here. Those two parallel. So how long is this parallel side? Well, the coordinates here will be 1 and f of 1. So f of 1, substituting 1 into f of x. So f of x is 1 on x squared. So f of 1 is going to be 1 on 1 squared, which is 1. So this length here is 1. Okay, so the height there is 1. Over on this side, over here, we're at 4. We're looking at f of 4. F of 4 will be 1 on 4 squared, which is 1 on 16. So this height here, this tiny little height here is 1 on 16. Okay, and the height of my row house, or my h for my row house here, is going to be 3. 4 minus 1 is 3. So my approximation, looking at my trapezoidal rule, we said that the area is approximately equal to h on 2. First one, so f of 1 plus f of the last one. Okay, and there's nothing in the middle, so there's no plus 2 business out the back at this stage. We can rewrite as well, so we can come along and say this is equal to, or approximately equal to 1 on 4 of 1 on x squared dx as well. So just evaluating our area, sum of all the paths between 1 and 4 of 1 on x squared dx is approximately equal to h on 2, so h f of 1 plus f of 4. So this is equal to h is 3 on 2. F of 1 we said was 1, and f of 4 was 16. So simplifying that a little bit, that's going to get us 17 on 16, and that's going to get us 17 times 3 is 51 on 32. So 51 on 32 adds an area, so it would be units squared in there. You don't need to include the units given there's no units up here, but that is how we would do a question. I'll grab another one just to get the notation right for us and just to really step through the process. So just another straightforward starting example. I'm going to ask you to use Simpson's rule to approximate this thing here. Let's go 0 to 3, and we'll say 3x plus 4 dx. So just as a sketch side note here, I've got a straight line that passes at 4. It's going to be quite steep. Oh dear. It's going to be quite steep. And it goes between 0 here and 3. So I'm trying to find this area in here. Okay. I need to find how tall it is. So what I would say, this is my function inside here, f of x. I need to find this height here and this height here. So those two, f of 0, f of 3. My x values of 0 and 3. So f of 0 is going to be 3 times 0 plus 4, which is 4. F of 3. F of 3 is going to be 3 times 3 plus 4, which is 9 plus 4, which is 13. Okay, so now my trapezium, I've got my side lengths, my parallel sides are 4 and 13. My height in the middle here is going to be 3. So I'm going to say that my integral, my area between 0 and 3, between 3x plus 4, the x-axis 0 and 3, is approximately equal to, and applying Simpson's rule here, sorry, trapezoidal rule here, h on 2, it's going to be then, let's check I did the last one. All good, yep. H on 2, it's going to be f of 0 plus f of 3. So that's equal to h is 3. 3 on 2 again, it's a coincidence. And then f of 0 was 4. Plus f of 3 is 13. So my area between the curve 0 and 3 and the x-axis is 3 on 2 by 17, which is approximately equal to 17 times 3 again is 51 on 2. Okay. That is how I would use my trapezoidal rule. Getting a bit more difficult. So just moving across here. Let's go and let's find the area between, let's get 0 and 4, and we'll say x squared plus 1 dx. And we're going to say here using 2 subintervals. And subintervals, you can think of subintervals as being like our houses or our trapeziums. So just for a diagram, what we're doing here, we've got x squared plus 1, so it's going to look like this-ish. You continue over there somewhere. And we're going between 0 here, and 4 up here. 4 there. And using 2 subintervals means we need to get our second house. So this is one house here at the moment. Putting a second house in, split it evenly down the middle, always go evenly. So it's going to be a 2 there for us today. My function values, well, I said this is f of x here. So f of x is going to be today x squared plus 1. I need to find f of 0 to get this height, f of 2, f of 4. So f of 0 will get us 0 squared plus 1. So this height here will be 1. I need to find f of 2. F of 2 is going to be 2 squared plus 1, which is going to be 5. Diagram is not to scale. And f of 4. F of 4 is going to be 4 squared plus 1, which is going to be 17. So this height here is 17. In terms of my trapeziums, I can do one trapezium, then a second trapezium. If you do that, like we did in the last example, first trapezium, second trapezium, in the end, add your areas together. I'm going to skip through and do it the method we did in the video introducing this topic, so I'm going to try and be a little bit sneaky. So we're going between 0 and 4, x squared plus 1 dx. This is approximately equal to, using the trapezoidal rule, h on 2. So h here is 2, so it's 2 on 2. And we're going to go our first one, so our first height here is 1, our last height here is 17, and then 2 times all the heights in between. So the heights in between here, the heights in common is just a 5. Okay, so simplifying that, that's obviously 1. That's going to be 10, 27, 28, so 28 will be my answer here. 28 units squared, it's an area. Okay, picking up, getting a little bit more tricky. So let's go, just give a second to load. Let's go and approximate now the area between, let's say, 0 and let's go 8 of x squared plus x, and we'll dx, and we'll do this using, we'll say 4 subintervals. So 4 subintervals, just to give you a diagram for that as well. X squared plus x, it's going to be somewhat parabola shaped. It's going to go something like this, I would imagine. Off the top of my head, I don't actually know. We're going here 0, 8's up the end here. So using 4 subintervals means 4 trapeziums. We're going to have 4 in the middle here. Split it in 2 again, 2, and we split it down here again. We're going to get 6. I would always split the middle and split them in the middle again if you need to. H is 2, and I've got 1, 2, 3, 4. You might also see sometimes they might say using 5 function values. 5 function values. And that means 1, 2, 3, 4, 5 lines. So 5, we're evaluating 5. We're finding f of 0, f of 2, f of 4, f of 6, f of 8. We're using f 5 times. F once, twice, 3, 4, 5 times. Back over here to actually go through and find what we need to now. This would be f of x. So we need to find here f of 0. F of 0 is going to be 0 squared plus 0, so that's 0. F of 2 is going to be 2 squared, so 4, plus 2 is 6, so it's going to be 2 squared plus 2, which is 4 plus 2, which is 6. We're going to look at f of 4. F of 4 is 4 squared plus 4, which is 16, plus 4, which is 20. We're going to come down and do f of 6. F of 6 is 6 squared plus 6, which is 36, plus 6 is 42. F of 8 as well. F of 8 is going to be 8 squared plus 8, so it's going to be 64 plus 8, which is 72. Okay, so we go through, we find our function values. Some people like to use tables as well, so you will see it in table form. You'll get x, you'll get f of x. The table form will say 0, 2, 4, 6, 8, and the bottom of the table will say 0, 6, 20, 42, and 72. So you might get that as well. Just bear that in mind. So sometimes they'll do it for you. They'll find the function values for you. Anyway, applying the trapezoidal rule, like we did in the last video, I'm going to just use the general case. So the area between x squared plus x, the x-axis, and x is 0, x is 8, is approximately equal to h on 2. So h on 2 here is going to be 2 on 2, because 2 is h. We want our first function value, our first one here, 0, 0. The last one here, 872, so it's 0 plus 72 plus 2 times everything in between, so 6 plus 20 plus 42. 2 on 2 is going to cancel. Evaluating this, that's going to be 62. It's going to be 68. 68 times 2. I'll get my calculator out for this, I think. 68 times 2 is 136 plus 72 gets us an answer of 208. So this is approximately equal to 208 units squared underneath the curve. Try and keep your working nice and neat. Okay, get your 5 function values, write out an expression showing that you know the rule, and then go through and evaluate it. I get it's tedious, I get there's a lot of working involved, and I would recommend drawing a diagram as well to get your function values correct, your subintervals correct. But yeah, do a few yourself. You'll find it, you get into a bit of a rhythm and it's okay. But feel free to come back, look at the video obviously. Go back, look at the video on the rule, how to get the rule as well, if you need to. Thanks for watching, and I'll see you guys later.